Next topic is 1.4 limits and continuity. Okay, let's just look at this example. Absolute value of the x. Just remind you, what is the absolute value? Absolute value of a negative number is a positive number. Absolute value of -2 is +2. Absolute value of a positive number, it will be positive, right? So, absolute value of the x. If the x is positive, see if the positive number will come out of absolute value without any change, right? If the x is positive, so it come out without any change. But like this example, -2, absolute value of -2. If you want to take out the a negative number outside the absolute value, you have to multiply it by a negative number to make it positive, right? So the answer is +2. So if the x is negative, this one, you bring x out, you have to multiply it by a negative to make it positive. So as you see, for the value of the x greater than 0, your function is y equal to x. This is the x positive, so this is the line of y is equal to x for the first. And when your x is negative, you have the line is y equal to negative x. Basically, this is the shape of absolute value. So it's a V shape. Okay, so this is definition of that. As you see, this is continuous. The limit from left and right exists. If I want to say that the limit of my function, limit of f of x go to 0 from right side. So from here, of course, is equal to 0. Limit of my function when the x go to 0 from negative value, so is equal to, if you x getting close to go from the left side, of course, the y getting to 0. And what is the limit of my function? Of course, the limit of the function exists. The limit from right and left are the same. So the limit exists and is equal to 0. Also, value of my function at 0 is 0. As you see, the limit and the value of the function both are the same and is 0. Therefore, it's continuous. Now, as you see, let's say I want to do the limit from 20 from right. The limit of the function from right of the 20 is equal to 5. So you can see that for t greater 20 is 5. And the limit from the left of 20 is 3. As you see, there's going to be that 3 here. Therefore, the limit from right and left of 20 is not the same. Therefore, the limit at 20 does not exist. As you see, this is a jump discontinuity. Okay, let's just do that. Limit of 5 when the x go to -1 is equal to 5. So we just don't have anything. Is a line is always 5. The limit of the 5 is going to be always 5. Limit of this function when x go to 2. Simply, instead of the x here, everywhere you put 2. See, 3 multiplied by 2 power 4 minus 5 multiplied by 2. You do it, the limit is simply 38. Now the limit of square root of 2x plus 5x go to -3. Simply, instead of the x, you put -3. And you see, this is a square root of -1. I know that negative value under a square root is not defined. That's why the limit not exists. Okay, you do the same here. Limit of x power 2 minus 4 divided by x power 2 plus 3 when x go to -1. Simply, instead of the x, you substitute -1. Instead of x, you put -1. Then you calculate the limit is -3 over 4. That's good. Limit of x minus 3 multiplied by 5x2 plus 2, x go to 0. you just, instead of the x, you simply put 0 and you calculate the limit. Now, limit 5x divided by x minus 2. Again, x goes to 2, and instead of the x, you put 2. See, in denominator, you get 2 minus 2 is 0. You know, under denominator, we cannot have 0. That's why this is undefined. Limit not exist. Now, limits and discontinuity. I just told you the case that when the limit from the right and left are not the same, we have a jump discontinuity. See, the limit from the right is, let's say this is L. So this is from right, you have to look at that. This is L. And the limit from left is M. Actually, I have to do that L and here to be M. Okay. These limits are not the same. We have jump discontinuity. Now we want to do the type of the discontinuities, right? There is another type of discontinuity when you have an asymptote. So this graph at x equal to 3, the denominator is 0. Therefore, you have a vertical asymptote at when the x is equal to 3, you have infinite discontinuity, vertical asymptote. Type of discontinuity is infinite discontinuity. As you see, I have to draw that, and then to draw the other half of graph, I need to raise my hand and come here, draw this. So the graph is discontinuous, and the type of discontinuity is infinite discontinuity. Now, point discontinuity or removable discontinuity. Let's say here is L, right? The limit from the right, this is A, and the x go to the A from right, the limit is L. And the limit when the x go to the A from the left, again, is gonna be L. The limit from right and left are the same and is equal to L. Therefore, the limit of fx, ax go to A is equal to L exists. But the value of my function, see this point here, this field point, is not the same as L. That's why when the limit and the value of the function is not the same, we have a point discontinuity or removable discontinuity. Here is this case are the same. The point does not exist. But again, the same situation. Limit from right and left are the same, but it's not the same as the value of the function. Again, this is removable discontinuity or point discontinuity. Now, some limits you have to simplify your result in order to take a limit. Okay, let's just look at this. I want to take limit of x power 2 minus 6x plus 5 divided by x power 2 minus 3x plus 2. What I do, I simply, instead of x, I put 1, right? So it's going to be 1 power 2 minus 6 multiplied by 1 plus 5 divided by here, and instead of x, I put 1, right? 1 power 2 minus 3 plus 2. In numerator, I get 0, and here 0. Whenever you get 0 over 0, you have to simplify your limit and then take the limit. How do I simplify? You just take, you write the numerator in a factorial form. So two numbers that if you add them is -6 and multiply them is 5. Of course, it's going to be -5, -1. It's going to be x minus 5, x minus 1. Here, the same thing, you write that in factorial form. Two number addition is -3, multiplication is +2. It's -2 and -1. So x minus 2 divided by x minus 1. I hope everyone know how to write that in a factorial form. So as you see, x minus 1 and x minus 1 canceling. So the problem is solved. You don't get, if you substitute x equal to 1 here, now you don't get 0 over 0 because this problem causing by that 2 that is canceled. Now this is now x minus 1, x minus 2. Now you just substitute 1 here. 1 minus 5 divided by 1 minus 2. You get -4 over -1, just 4. This is another type. Again, you have to Simplify. How do I know I can simplify? Just put 0 when the x go to 0, this expression, instead of the x, you put 0. You get a square root of 4 minus 2 divided by, you just put that 0. Square root of 4 is 2, 2 minus 2 is 0. Again, you get 0, 0. Again, when you get the type of 0, 0, you have to simplify. Now, how do I simplify this one? Just remember, I want to get rid of this square root, remembering that a minus b multiplied by a plus b equal to a power 2 minus b power 2. So the same thing, I want to simplify 4 minus x, 4 plus x minus 2, right? I want to get rid of this root there. What I should multiply by that, I should multiply it by, this is a minus b. Here is a, here is b. The addition of that, 4 plus x plus 2, right? Then if you do that, what do you get? You get this one power 2, which is 4 plus x minus 2 to the power of 2. C is a2 minus b2, which is 4, which is going to be x. Now, so we have that. We need to multiply numerator by the square root of 4x minus 4 minus x plus 2. Since you multiply, you have to divide by same thing because you don't want to change the whole things, right? You divide and multiply by same thing. When numerator multiply by that, if you simplify, it will become x. Like this multiplied by that is just x. And then you have the denominator, which is x multiplied by this. 4 minus x plus 2. Now, limit x go to 0. Now, see x and x canceling. Now, our problem is solved. Cancel x and x. You simply, instead of the x here, you put 0. It's going to be square root of 4 minus 0 plus 2. Square root of 4 is 2, so it's going to be 1. 2 plus 2 is 4, is 1 over 4. That would be the answer. So here is another question. Limits 1 plus x power 2 minus 4x plus 3. If you put -3, so 1 plus -3 is -2. -2 power 2 is 4. 4 minus 4 is 0. We get 0 in numerator. And -3 in denominator, -3 plus 3, we get 0. So it gets 0, 0 again. We have to simplify. I'm going to expand that. The first number power 2 plus twice of the first multiplied by second number, 2 multiplied by 1 multiplied by x, 2x, and the last one power 2 minus 4. So the number and the number, so it's going to be x power 2 plus 2x minus 3. Then I write this one in a factor form, which is x plus 3 multiplied by x minus 1. As you see, x plus 3 and plus 3 cancel. Then the problem is solved when you cancel things, right? -3, just substitute x -3. You have -3 minus 1, which is -4. The answer of this limit is -4. That was the last question. Now this is the worksheet that you do. Here, the question number 1, the type of discontinuity you need to tell me. Question number 2. Question number 3. Question number 4. Also question number 5. Question number 6. You do A, D. A and D. Question number 7, you do A and E. Question number 9, just do the last one, F. Question number 10 you do, it's very important. Question number 11.